So based on your email invite, these are generally the topics you want to cover, which I'll be attempting to cover within this short hour and a half. First, I'm going to show you how to use the Git help documentation if you don't already. I explain a little bit what the DAG is. That's how Git stores stuff internally. And we'll basically plow through all of these items, which will mostly cover what you had requested, along with some of these extra scenarios that don't quite fit into that outline very nicely, which I just sort of appended to the end, that we can tackle once we cover the core basics of everything. So has anyone used the Git help documentation before? Like, you ever use Git help on the command line at all? So that's the first thing you should familiarize yourself with, is Git help. It gives you a number of commands in which you can check out that Git supports. And there's more than just this. If you notice at the bottom it says you could also use Git help -a, and that shows you the full list of everything. For every command that you're doing, there's help documentation to it. So for example, if you want to clone a repository but you don't know what options you have, you can say Git help. Okay, yeah, look, there's clone right there on the screen, so you could say Git help clone, and then there's a full documented manual page on all the options available to you, and you use Q. The pager is less, so you use Q to quit the documentation. Let me see here. So I went ahead and created a repository for us to use in this session. But before we start messing with that, I want to explain a little bit about the internals. So what Git uses to store internally is what's called the DAG. You'll see it a lot on the internet. It's referred to as the DAG. The DAG is basically a computer science concept that we won't dig too deep into, but it stands for a Directed Acyclic Graph. It's directed in that it only goes one direction, from old history to later history, and it's acyclic, meaning it never forms a circle. So objects can never reference back to earlier objects in a way that when you follow the chain, you go in a circle. It's acyclic. So let's talk a little bit about what makes up a commit object, because that will further help you in understanding a little bit about the DAG. So I'm going to go ahead and I'm going to go to Git Gerrit. Going to create a Git Training repo. And to create a repo, you just do git init, you might have seen. So if I do ls-a, you'll see there's a .git directory right there. I'm going to touch a README file. You can see that when I do git status, it's untracked because I don't have any commits yet. I'm going to go ahead and add dot. If you use a directory, it will add anything under the contents of that directory. In this case, that directory is going to be a dot, so it's going to add the current directory as well as anything contained therein. If I do a git status again, you'll see that I have a new file. I'm going to commit it and just say initial commit. So I kind of sped through this because I want to get to an example of a commit so I can show you what's in it. So I'm going to use the show command. So I'm going to git help show, or no, I'm going to git show. I'm going to show you a raw commit. So this is a raw commit object inside of Git. You notice that there's an author, there's a committer, there's a date associated with each. So that means for example, if you have vendors or people who are contributing to your repositories elsewhere, they could say, hey, here is my changes that I made in Git remotely. I'm emailing these patches to you, and you can say, okay, it's different author, but you're the person committing it, so that's why there's kind of a disconnect between the two, because who authored it may not be who is committing it. One thing to notice here, actually several things, I'll just go down the features as soon as I find my mouse. Okay, so every commit object has a SHA-1 hash. That hash is the hash of everything in the commit object. So right here you don't see, in fact we're actually missing one thing that I'm looking for, so let me make one more commit. So let's ignore my shorthand commands. I'm just lazy. So a couple things in this is you have the commit, which is a SHA-1 hash of everything in the commit. The tree, which is the tree associated with all the commits in your repository, as well as the parent commit SHA-1 hash. So that means you have a tree here. If I do a git log, you see that you have this comes after this. So that means this commit here is this guy's parent. And so you see that hash here. Here's the parent hash associated with that commit object. Also part of the commit is the commit message, and then the diff changes associated with what is being changed for that commit block. So that being said, this SHA-1 is the combined data contents, the SHA-1 hash of this. Does everyone know what a hash is? Are we all familiar with SHA-1 hashing? Okay, cool. So I don't have to cover that then. So yeah, so a commit object's identifier is the SHA-1 hash of the actual commit object. And so that being said, this is how Git keeps track of integrity as well, because everything is hashed, and so you can use a FISC to check the integrity. But so that's a commit object. Let's do a brief overview of the references. So also in our Git help documentation, we have, which is not showing up right here, there is a Git revisions. Where is G? No, it's in here. Now it's making me a liar. I know there's a revisions doc. But in any case, we're going to go over what makes up. So right now we only have one branch. So the only reference showing up is refs heads master. Let me go to a more complicated repository because it's not very clear here. So let me go into something that has a couple of branches. Let's go to CF Engine. So here you see there's lots of references in here. If I look at the Git tree, which is that alias that I sent you originally, you'll notice that here you have on one line each commit hash and then its revision that's pointing at it. But you also, somewhere in here is the head. And so what the head is the head is your working directory. So you can always be confident that whatever your working directory is, if you reference head, that is the hash you are currently working in. So you'll see a lot of commands that reference head. There's also a fetch head, fetch underscore head. So git. Haha, it didn't make me a liar. Okay, so there is doc here. So this help page, the Git revisions help page, will explain all the stuff here that I am talking about as far as the revisions go and things like that. So So you have your head. Your fetch head is when you do a git fetch on something. Like if you fetch a branch, the branch will be in the fetch head remotely. So fetching does not imply that you've updated your working copy. You've only fetched the remote things into the remote part of your internal database here, which is the DAG. Refs heads is, so if I do a git show refs heads is your branches. So if I grep for heads, so this has 3 branches. Refs tags is where tags live. So it looks like there's a SQ tag that someone should not have pushed. That's unrelated to this project. But anyway, so refs slash heads and refs slash tags are your locally tracked things. So when you're working in your local branches and you're checking out branches and you have your different workspaces, all that's going to live in refs, heads, branch name, refs, tags, tag name. Now let's do a git fetch again just to make sure we have everything. Now if we do a git show ref, look here, you have refs, remotes, origin, branches, home. So all in the same repository, the remote origin is being tracked. So all of these are just pointers. They're pointing to the hashes, the actual commit objects. And so when you have an upstream branch that your master branch is referencing to track changes, it is referencing one of the remotes branches. For instance, if I do a git branch -v, you see that I'm on master branch. I'm ahead 1 behind 21, but if I do a git branch -vv, you see that here, you can't quite see it. There you go. My master is being tracked by origins master. And this is how it can tell the difference between me being ahead 1 behind 21. So to think about that a little bit, how it knows that it's in that state, if I do a git tree and I go down to where I'm at, head, you see that here is a change that I have not committed yet. I haven't rebased, I haven't done anything with it. But since I haven't committed it, I've made this commit, so I'm ahead 1. So here's where I checked out from at some point in time. I'm ahead 1 because I have not committed. But in the upstream branch here, people have made 21 changes. So origin master is 21 changes ahead of the state I originally checked out and committed my changes to. And so that's how it knows between ahead and behind, is by tracking its remote tracking branch. Its upstream branch is what it's called in the documentation when you see it. So that pretty much summarizes how the references are organized and how they all relate to each other. So I'm going to give you a quick overview of how Gerrit's changes are. So I'm going to log into Gerrit real quick. So let's go to the CF Engine repository, just since we're already messing with this and looking at it. So if I do a git show ref here, you're going to see a lot more references than what, it'll take a second to come up, than what you have locally, because not only do you have your refs heads and refs tags and all that stuff, but you also have here changes. Gerrit tracks all their changes with git references. So when you do a git push head refs for master, it dumps head refs for master is an interface that is not Git. It's something that Gerrit intercepts, and then when Gerrit gets that information, it automatically creates a reference inside of your Git repository with all your changes. And so as you're making iterations and updating it, it's keeping track. So you see here, here's 2 patch sets for the same thing. You have for change set 33703, you have a first iteration and then a second iteration. This is how it keeps track of it. So this is how Gerrit is doing it under the hood, which you will never typically interface with unless you download the commit yourself. And we can talk about that towards the end if you like, on how to download a commit. It's very useful. So that's Gerrit storage. One of the topics you'd asked me to cover was pushing and pooling. So let's talk a little bit about that. So if I go, and if I'm going too fast, or if you need me to slow down, or you want an explanation of something, feel free to interrupt. This presentation is total ad hoc, so I'm not gonna like flame anybody for it. So feel free to interrupt. So I'm going to continue using the CF Engine repository for this presentation just because it has so much content in it and so many examples, but we won't actually be demoing it here when you guys are playing with stuff. So let's talk about fetching. So let's go ahead. Let me look at .git. So inside of .git you have several different files. You've got a hooks folder, info, logs, objects, refs, and so this is where it stores all of its objects by its SHA-1 hash. They're actual files, but we don't need to look into them right now because this has a lot in it, so it's not going to be very useful for you to see a whole bunch of junk. But you see here some of the references that I mentioned before. This is how it's checking its hashes. You've got fetch head here, and origin head. So here's, and if I open this file here, well, that was probably, there's a lot of fetch heads. But if I look at head, it's just going to have one because there's only ever one. It's to let you know where it's referencing. So if you check out a hash, this ref will be a hash. If you check out a branch, it's going to say which branch. Or if you check out a tag, it's going to say which tag. But one of the things I wanted to show you for fetching is here, when you fetch from something, it's saying this is the line that does all the magic as far as how Git knows how to organize its internal database. So if we look at the help documentation, so I'm gonna say git help git config, and I'm gonna git help config, and I'm going to look at remote dot, and that's, let me search again, remote dot, so it's not a glob. So here we have all of the different definitions of all the things. So let's look at remote.fetch. The default set of refspec for git fetch, C git fetch. Well, what am I going to do? I'm going to git help fetch. And so here, let's look for refspec. So here, they've defined the refspec for us. The format of the refspec parameter is an optional plus, followed by the source ref, followed by a colon, followed by the destination ref. The remote ref that matches source is fetched, and if destination is not empty, the local ref that matches it is fast forwarded using the source as a reference. If the optional plus is used, the local ref is updated even if it does not result in a fast forward update. That is to say, if it has to force and overwrite what is there and it's not like a clean update, it'll just do it without like throwing any errors. It just forces it. So going back to here, if we look at .git/config here, you see that we've got our optional plus, so it's going to force update when it fetches. It's going to force from the source, and the source in this case is this repository URL. So it's going to download the ref's heads reference from this repository and go ahead and drops them inside of ref's remote's origin with matching things. So all of your references, this is how Git is tracking all of your remotes. So as you add a new remote, it's going to drop it into a different remote space. And so this is how Git is able to internally track all the remote changes and keep track of everything simply because the way Git stores all of its objects is by SHA-1 hash. And so these branches and pointers are only pointing to SHA-1 hashes. And so that's how it's able to, keep track of everything. And multiple pointers can point to the same hash. So that's fetching. Pushing is similar. So you notice here there is no push. I'm not going to look at the documentation. I'll just tell you what it says. essentially, by default, when you do push, it'll push refs heads to the remote's refs heads. So whatever you have locally, it's going to push to what it is remotely, to the exact same namespace remotely. So in this case, if we were to push and we're pushing our refs heads, it's going to land in refs heads remotely. And so that way, when we push our refs heads and remotely the refs head is updated for whatever branch we're pushing to, let's say master for example, then later when we go to fetch, it'll then fetch that change that we've pushed to refs heads and go ahead and update our remote origins master with that change. And that's how it keeps them separated. Is everyone clear on that, or did I go a little fast?
Yeah. Lost.
You're lost?
Yeah.
Okay. So going back, git show ref. You see here, this is how Git keeps track of everything internally. To the right are pointers. They're human readable things that point to Git objects. The Git object being a SHA-1 hash. So, you could git show an object, a SHA-1 hash, and here it is. So I mentioned that by convention, all of your local branches are stored in refs heads.
Right.
Always.
Right.
So refs heads master, when you check out master, you've actually checked out refs heads master, and it's got syntax sugar to just show you, hey, you're on master. And under the hood, it knows that it's in refs heads master. That means remotely, if we do a git show ref on the CF engine repository inside of Gerrit, it's also going to have a refs heads master, right? So let's go a little bit hypothetical here, and let's pretend we're in the process of designing Git. How would you be able to fetch the remote's refs heads master without stepping on your own refs heads master? What do? You put it in a different namespace.
Is that the origin?
That's that origin namespace, yep. So if I look at the git config here, you see, okay, it's going to take everything on the remote that lives under refs heads. And it's going to go ahead and dump it inside of locally on my system inside of refs remote's origin. If you recall when we were looking at the destination, it was a plus sign, source, destination. And since we're fetching, you got to remember we're downloading. So that means the source is where we're fetching from, which in this case is the Git repository. The source reference is refs heads on this Git repository, and the destination is going into refs remote's origin on our local repository. So is that a little more clear?
Yeah, that's all clear. I mean,
okay.
I don't know about it. Like that really helps. Like explaining it like I'm 5 hours.
That's cool. So here we'll do a git show ref and we'll grep for origin. So here you see refs refs origin. There's our master branch. Refs remotes origin master. It went ahead and dumped master inside of refs remotes origin. And so this is essentially how it's tracking. And the only reason why, don't get fooled by this, because this branch name is actually called branches / something.
So that list right there, you're referring to all those are all remote branches.
These are all remote branches, yep.
Right, and so those are all referred to as so when you say you push origin jump master, you're pushing to that remote repo jump master, basically.
Yeah, so when I was talking about pushing, well, let's go ahead and look at the help documentation. When I was talking about pushing, the refspec is the same. It's a source followed by a colon followed by a destination, and then somewhere in here it's going to mention its default behavior. I don't see it real quick by skimming, but essentially what it does is if you don't have a custom setting inside of refs and inside of git config for pushing, push is equal to inside of your git config for that remote, what it's going to do is going to say, oh, I don't have anything here. So I'm going to assume you want to push, if there's a reference on my end, I'm going to push to that exact same reference on the remote end. So in your case, if you're developing locally in refs heads master, when you go ahead and do a git push, its destination is going to be the remote repository, refs heads master.
Okay.
And then when you go to fetch it, remember we're dumping it in a different destination. So when you fetch the remote refs heads master, it's going to populate inside of your refs remotes origin master. And so that's the difference between the pushing and the fetching, is because when you push, because there's nothing specified there for what you're pushing, it's going to automatically assume you want to push only what branch you're on, but also in the same ref path remotely. So if you're in refs heads master, it's going to push to refs heads master.
Okay.
It's not going to try to put it in any special namespace. So we good with pushing and pulling and how that works a little bit under the hood. It's kind of advanced. Not everyone really has to know that, but I feel like knowing that kind of helps. And so if you're cool with that, I'll talk a little bit about branching while we're at it.
Yes, you guys good?
Any of you guys have questions on what I talked about? All right, so let's go to our Git training. Where did it go? Oh, wow, I combined the T's. That's terrible. All right, so let's do a git show ref. So right now we only have a refs master. If we do a git tree, we'll see that we have 2 commits, and the only thing putting out our latest commit is head, which is our currently working directory, and the branch master, which is local, refs heads master. If I want to create a branch, you can do it one of 2 ways. And also, let's look at the git branch command. You can do git branch, and git branch will actually show you what branches you have locally. So right now we only have master, and this little star indicates we're on the master branch. So if I do a git branch test, what that's going to do is it's going to create a test branch, but I'm still on master. It's not going to actually switch to it. If I wanted to create a branch and switch to it, I would do git checkout -b, and you can look at git help checkout to learn more about the options. Git checkout -b test2. Now if I do a git branch minus, you see that I've created a test2 branch, but I'm also have it checked out. Now let's go ahead and look at our git tree again. Check it out. Same commit object. Only difference is you have 2 extra things that are pointing to it. So they're all pointing to the same git hash because git internally tracks only the hash of the object and then the reference pointing to it. So here all the references are pointing to the same object, so that's how it's organized. Now let's say git branch -v. Oh man, I just created a 0v branch. We'll leave it. Yeah, I do that all the time. So we're on the test2 branch. I'm going to go ahead and check out the test branch. Git branch. You see I am now on the test branch. So if I make a change, vim readme, and I say another change to git status, git diff. Here I have unstaged changes. If you try doing git commit, it won't work. So what you have to do is you have to stage it. Git add readme, git status. Now notice here, git diff only tracks unstaged changes. So if I do git diff again, nothing shows up. But if you want to track the changes in your stage, you would do git diff cached. So here, if you have some changes that have been added and some changes that you've been made, you can check across the 2 to see the status of your repository. So git status. So now I'm going to go ahead and commit this. Git commit I'm going to call it another change to git status. So now on branch test, nothing to commit, working directory clean. So now if I do a git tree again, our tree is, our head has moved up a commit because it's our current working directory, and our test branch is advanced. But if you notice here, we haven't modified any of the other branches, so they're still pointing at the last commit object they knew was theirs. So that's it. That's Git. It's just pointers pointing to commit hash objects. So let me go ahead and add a Gerrit remote. So let me.
I'm sorry. Which branch were you? Okay, so
I'm on the test branch.
you're on the test branch.
So
that's why the test is pointing to that new commit hash.
yeah. So if I do a git branch, I am on the test branch.
Okay.
And for me, I personally like doing git branch minus v, give it a little bit more verbosity, because it also shows you which hash that branch is at, along with a short commit message.
And that head, that's a pointer that always points to the current commit.
To your current working directory.
Oh, okay.
So here, ls, I have some contents here. Head is pointing at whatever commit object I have checked out here. So if I do a git status, git log, and I go to the very first commit, and I check it out. And this kind of falls into your question where you mentioned, how do we go back in time, check out something else. Here I am checking out a commit object by its hash because I pulled the hash from the log. Now if I do a git branch, you notice that I've detached. There is no branch or reference referencing this. It's just a raw commit that I've checked out. If I do a git tree, you notice I've checked out the commit object. My working space is inside this commit object, so my head has moved. I'm not inside of a branch, but the head always tracks whatever commit object you have checked out.
So how do you feel about the being attached to that?
It doesn't bother me. It only matters if you're making commits. And so when you start making commits in this state, so git status vim readme some other change, and actually this will segue nicely into merge conflicts. Git status git commit some other change. Now if I do a git tree to look at my overall tree again, you see here's my other commits that are tracked by branches, and then I made a commit, but it's just there. I could look at my ref log, and I think it shows up there. Yep. So let's say if I do a git status git tree, and I say checkout test, git checkout test. You go, oh no, git status, git tree. Oh, the change I made's gone. So you can use the ref log, git ref log, to look at the history of your head of all your checkouts and say, oh yeah, here was that commit. Okay, some other change was the commit message, so I'm going to check that out again. And by the way, the hash here, as long as it's globally unique, it could be any number of length. It doesn't matter. Looks like it's too fancy for it. But it could be shorter, it can be longer, as long as it's unique across all of the objects in your repository.
So basically, like if you checked out another branch and you didn't save that commit, like you can look through your ref log and see what.
Yeah, you can look at your ref log and see all the times that you've changed heads and see where you were last. And so that's what I did. You see, I just recovered it. I checked it out again, and here I'm back in that state. So okay, well maybe I want to create a new branch here. So I'll git checkout branch, checkout minus b to create a new branch, and say my changes branch. And so now if I do a git branch, I'm on the my changes branch, and if I do a git tree, you'll see here that head has now got a my changes branch pointing at it. So now this will actually segue nicely. So there's a couple of things you can do here. So let's say we want to merge this into test. Let's pretend test is master. And let's say you're working in a branch and you want to merge it. This is an emerging workflow. This is different from working in Gerrit. So now what you do is you get branch minus v. I'm going to get checkout test. And I'm going to get merge. I prefer no fast forward merges. You can check out the documentation later to see what no fast forward merges are about. But when you're operating on GitHub and you click that little merge button, it's doing a no fast forward merge. The reason why I like doing a no fast forward merge versus a fast forward merge is because what a no fast forward merge will do is it'll actually show the history that a branch existed. So it will actually, if you look at the Git log, it'll show, hey, I've branched off, made some commits, and then merged it back in. Whereas a fast forward merge would go, let me just smash all that together and just pretend all these commits were made on this branch. So that's the difference between the two. And I personally just like knowing the fact, hey, I branched off here at some point, made some changes, and then I brought it back in. So that's why I personally like it. So now what I want to go ahead and merge into here, I'm on branch test. I'm going to no fast forward merge my changes. And so since I'm on test branch, this merge command will merge the changes that are in my changes to the test branch. So let's see what happens. There's a merge conflict. Git status. You have unmerged paths, fix conflicts, run git commit. Use git add file to mark a resolution. So here we see both modified, meaning both from our merge commit and our commit inside the test branch, there is some conflict in here that we have to resolve. So if we look at this file, you see here, head has another change too, and then my change branch has this. So here, this marks my head. This marks what branch I'm trying to merge from. And it's saying, hey, in your current branch, this is what you have, but in your other branch, this is what you have. And the reason why it encounters this merge conflict is because if we were to check out my changes branch again and look at this README file, this line, some other change, would be on line 4. And so since that specific line conflicts with what is in here, Git doesn't know what to do with it. So it says, merge conflict, I need a human. And so here, it shows you what is conflicted between the two and says, hey, in your head, you've got this change, but in this other branch that you're trying to merge in this exact same spot, it has this change. So here, let's say we want to resolve this and say, oh, you know what? I kind of like what I did in both, so this is only documentation and not code, so I'm just gonna keep both, and maybe I'll even modify it a little bit and give it a little bit more sentence structure on one line. And now I've resolved this conflict, but Git doesn't know I've resolved this conflict. So if I do a git status, Git still sees, oh, both modified, and it's going to remain in that state. But if you look here under unmerged path, use git add file to mark a resolution. So I'm going to git add readme. Now if I do a git status, changes to be committed, use git commit to conclude the merge. So really all it is just following the instructions as once you generally know. I mean, I know when you see this for the first time, it's not clear and it's kind of cryptic. But since we're here going it, hopefully when you see this in the future, you go, oh, okay, I know what's going on. So here we've got our changes to be committed. So now I'll do git commit. I have a new message. It showed that there were conflicts here. I'm just going to leave that in the message. And you can modify this message if you want. I'm not going to. So now if I do a git tree, a couple of things happened here. First, it organized all of the commit messages by the date they were committed. And it did that originally before, if you recall, because this was above these two before because of the time it was committed. But it also created a merge commit. So let's analyze a merge commit a little bit. Let's look at the raw object. Git show. Let's look at the pretty option raw so we can see a little bit about it. And let's look at head. So here, oh, look at this. It's got 2 parents now. So this is how Git tells the difference between a regular commit that is linear and has only 1 parent versus a merge commit that might have multiple parents. Is if it's got more than 1 parent, it's a merge. Now, this is branching and merging. It's very simple. It's all pointers, and you notice, as I've been doing this, I've been purposefully hanging myself and then also showing you how I'm getting out of it. So Git gives you enough rope to hang yourself, but it also gives you a little bit extra to kind of undo it too. So let's...
I have a few questions about the branching.
Sure.
Let's say I'm on Git master and I create Git branch, let's say A.
Mm-hmm.
So I'm on Git branch A right now, right?
Mm-hmm.
And if I'm doing all the changes locally, it will be on the branch A itself.
Yep,
And
only
then-
locally though.
Only locally. And if at the same time I create branch B,
Mm-hmm.
then does B will also have the same changes?
So it depends where you create branch B. If you create branch B from your currently checked out location and you're checked out at A, the branch B will be created wherever your head is. So if your head is checked out inside of A, it creates a branch B right there at the same place.
So it means
So it's not going to assume that you want master. It won't know if you create a new branch.
So the branch B will have the code of branch A, right?
Yep.
And on the branch B, I do git commit
Okay.
directly to the master.
Yep.
Then
So that means you've only advanced B. A will not have those changes.
A will just there itself, right?
Yep.
With the
All the branches are
previous
self-contained. Because if you remember, all those references are just pointing to objects. So B knows what objects knows the head object that it is pointing to, and A is also keeping track of the head object it's pointing to. So if you check out B and make a commit, and B is now pointing to a new object, A is still pointing to the exact same object it always knows. If you wanted to get into B state, you would have to check out B and pull in the changes from B to A. So that would be a git pull in that case. And so in that scenario, git pull will work if you mention the branch name. Actually, I don't know. I don't want to make that assumption. So I'll just leave it at that. Do you understand that much though? Ignoring pooling and all that. You understand how the branches are pointing at objects, right? And so if you're in another branch, or if you check out a branch at that object, that's a whole nother branch that is independently pointing at an object. So if you make a commit in that branch will advance without touching any other references. So that is the magic. That is all the magic unveiled between Git branching. This is a merging workflow essentially.
So when there is a merge conflict, is there a way to force Git to just take whatever I'm committing?
There is. So let's look at our handy dandy documentation. Git help merge. So scrolling down through here, there is such a thing called merge strategies. If I'll ever get there. Merge strategies. Resolve, recursive, you could say, oh, prioritize ours, prioritize theirs. And you could say, hey, I don't care what's in the other branch. Force merge it, take my changes, discard their changes.
Okay.
So this is how you do it. I'm not going to really get into detail and show you a working example because this is a little bit advanced, but a little bit advanced for the discussion we're having here. But certainly it's doable, and reading the documentation will help unveil that mystery.
Thank you.
Yep. So we've gone over branches and merging branches. What happens during a rebase? Let's talk about rebasing. So here's our Git tree. Oh, I'm in the wrong repository. I'm in the wrong screen here. So let's look at our Git tree again. Let's pretend that we never merged my changes. So let's say, oh, Git check out my changes, Git log. And so Git log shows that I have the initial commit and then my commit. But let's say I want to rebase. I want to rebase from the test branch. Or even better, from the master branch. So let's git checkout test2. Let's git checkout master. So master is here. This is where our local master is. So if you notice here, we're ahead by one commit from master, but we're also behind one commit from master because a commit has been made. Notice how this forks up and goes all the way up here. So one commit has been made in master since. So let's say we want to rebase. Let's talk a little bit about what rebase does. So let's go to the whiteboard here. So you have a series of commits. We'll say your head is here, your master's here, and let's say in a hypothetical scenario, you're in your local master, and then let's say we're also our origin master is here because you've cloned it. You've cloned it, so you have an origin master, a master, and your head, all pointing to the same SHA-1 commit object. Let's say you make some changes. So let's say you make 2 changes, for example. And now your head and master have moved to those 2 changes. But, origin master is still pointing to the thing it always points at, because if you recall, when we make a commit and modify one reference, it doesn't touch any other references. So origin master is still pointing at the state that my repository last new origin master was at. And let's say hypothetically that you guys are on a team and you're all developing on the same branch, and so someone pushes to origin master. And so origin master has off some commits. Let's say someone pushes 2 commits. When you do a git fetch, what that's going to do is it's going to fetch all those changes into your remote origin master. I'm going to call it O/M because I'm tired of writing origin master. So here, origin master is in a slightly different state. So if you were in this scenario and even if there wasn't conflicting things here, if you were in this scenario and you simply did a git pull, what do you think would happen if you did a git pull? By default, it'll do merging, kind of like that. So when you do a git pull here, it'll say, oh, well, origin master's kind of branched off here, so since you're going to git pull, I'm just going to go ahead and create a merge commit. We'll do that. But that's not typically what we want when we're working with Gerrit. When we're working with Gerrit, we want to do rebasing because we're all developing on the same branch, and the way that we have it set up here is we don't really allow merge workflows like this. So what you have to do then is you have to rebase your work. What does rebasing do? What it does is it first rewinds head to here, fast forwards to origin master, and then it replays your commits on top of it once it reaches to that new state, as if you made them at that time. And so now your new head origin master, or your new head master is up here. Head and master branch is up here. Now if you recall, the SHA-1 object is the contents of all the stuff in the commit, but also remember the parent SHA-1 hash is part of that hash. So because these guys have new parents, their hash has changed. So these are whole new commit objects. These guys still exist. If you go, oh, I didn't want to do that, these still exist in your Git repository, and you can go find them, and you can check this out and move your master branch back to there if you really wanted to or if you really needed to. So this is one of those things I was talking about. Git gives you gives you enough rope to hang yourself, but also unhang yourself, is because it tracks everything by SHA-1 hash, these are whole new objects. And so that is the mystery of the rebase. And that's it. All it's doing is it's keeping track of an upstream branch. And if there are changes that have been made in the upstream branch since when you've made it, what it'll do is it'll first rewind it to the part of when your changes and the origins branch have come together before you guys branched. Then it'll replay the changes of the origin master's branch, and then it'll replay your changes, it'll fast forward the changes to origin master, and then it'll replay your changes on top of that. And this is akin to cherry picking. It's essentially cherry pick this commit to here, and cherry pick this commit to here. And we'll get to cherry picking, but that's essentially what a rebase does, is it cherry picks a whole group of commits. And so that's rebasing. Are we all kosher and understand the rebase? Any questions? Louis, you look a little puzzled.
So origin master would just stay pointing at that object over there. That master would move to the latest. And if you want to reference your old commits that had the old parent hashes, you can do that.
Yeah.
Fine. Okay.
And in fact, before your rebase, if you copy that whatever hash you're at, so if you know you're going to do like kind of a scary action and you're like, I don't know if I'm comfortable with what I'm about to do, save whatever commit hash you're currently at. That's going to be your save point. Just save it in another text file if you don't want to figure out all the specific commands and cryptic deep diving to figure out where all the stuff was. If you save the commit hash of your object, you can always check that object out later, as long as you don't garbage collect. Because garbage collecting will find things that don't have references and snip them off and remove them from your repository. It's a maintenance task. But Git does not do garbage collecting by itself. It has to be an action that is made with intent. So you have to actually run the garbage collect command. So it's not something you have to worry about.
Okay, so it doesn't happen routinely.
No.
Cool.
Because it cleans up and actually deletes things.
Yeah.
So it stops you from being able to go back.
Right. Okay.
So it's a destructive action.
How long does your references stay there?
Forever.
Forever.
As long as you don't garbage collect. That's what I was talking about. Your references will stay there forever as long as your repository and your local disk is in existence. Meaning you don't delete it. Another cool trick that I like to use is, you can rename master to be something else. So let's say your master gets into some totally waxed state and you're like, oh no, I don't even know, my Git tree looks like a star. I don't even know what's going on. There's crap all over the place. I don't like it. I'm just gonna delete my repository and start over. You don't actually have to delete your repository. What you can do is use git branch -m. -m is rename, and you could just rename your master to junk. And then when you do git checkout master, it's going to say, I don't have a master. Who has a master? Origin has a master. Let me check out Origin's master and create a new reference called master locally for you to do. And so this is a really good trick to, if you accidentally get into a messed up state, you can rename whatever branch you're on. You can rename your current master to something else that is not master, and then when you do a git checkout master, it checks out master based on Origin's master, so it kind of resets your state a little bit. So, but as far as rebasing goes, I know we got off a little on the tracks there. Are we all cool on rebasing? We understand that because these have new parents, their SHA-1 has changed, so they're whole new objects. These objects are still in existence. And to rebase, what happened, the situation why we had to rebase is because we're all developing on the same branch name, master. And so, different people might be making changes at different times. So when I check out my repository, someone might have made changes by the time I'm ready to commit. So what you do is you pull in the changes that other people have made, and when you rebase, it rewinds to the point that you last checked out master before you made your changes, fast forwards to the current state of master and then replays your commits on top of that. So, we clear? Cool. So and understanding rebasing is really hard if you don't really understand the internals a little bit, how the objects work, which is why I started out explaining, a little bit about the DAG and what makes up a commit. Okay, so if you recall, if you've ever developed in Gerrit, you'll know that when you're developing, Gerrit tracks it by its change ID, its change set ID. And if you want to make changes and update that patch set, you got to amend your commit, right? So you make your changes, amend your commit, push head refs for master. So what happens when you amend? Okay, let's erase this now. Let's start over. And let's say my simple repository has 3 commits in it. We'll say it has 2 commits in it. Origin master is here. I've made a change and made a commit. My master is here, as well as my head is also here. So head and master is adding this new commit. Inside the commit message, I have my change ID that Gerrit uses to track. It's right in the commit message. Has that change ID that Gerrit uses to track your changes. And so let's say you make some changes here. You say, oh, in my code, I want to call Google instead of Yahoo in my code. So, you make your code change, you git add your file, and then you do a git commit -- amend. So what happens? Remember what the SHA-1 is made up of. It's made up of everything in a commit object, which includes the diff, it includes the commit message, what parent commit hashes there are, as well as the tree that it's a part of, the author, the committer, all those things. So if you amend any one of those things, what do you think happens to the hash? Right, your hash changes. So you make your changes, you say, oh, you know what, amend, you have a new commit object, your master, head is there. Your old amend still exists. The old commit that you amended from still exists, that object's still there, but you've amended, and you have a whole new commit that will no longer show up because this is not pointing, nothing's pointing to this. So when you do a git log or git tree, all you see is a line. And so this is what's happening. And as you make more amends, it just creates new objects because you've changed the hash. And so that is the mystery of amending a commit. And so when you amend it, Gerrit's tracking the hash, your hash, along with the contents of your commit. And so it knows if you've pushed this commit yet. So if you do a git push head refs for master from this thing twice, it'll say, oh, no changes. Because the hash is still the same. I know you have not changed anything, so I'm just going to say, burn. You haven't changed anything, your change set stays the same. You make your changes, you amend it, you've got a whole new hash object, and Gerrit goes, you have changes. Let me update your change set. Let me update your patch set with your new changes. And so when you do a git push head refs for master, it is pushing into Gerrit a new change set, and then it's able to tell the differences between these two because they're different objects. So you can diff 2 objects even. So as far as amending commits, we clear? Okay. Let's talk a little bit about. So we already talked about merge conflicts. I have left to talk about is stashing and cherry picking, but before we do that, let me backtrack a little bit and talk about that Gerrit push command so you can start thinking about that source. So you can start thinking about that refspec, if you recall. So you have git push the remote. In our case, it's usually origin because we've cloned it, and clones always by default get dumped into origin. Head colon refs for the branch name. In our case, we're usually branch. I'm writing sideways. And the only reason why I'm doing it this way is because I'm recording and I want it to go off the screen. So head, what's head? It's our current state, right? It's whatever we have checked out. So you could replace head if you really wanted to be a jerk. You could replace head with the commit hash that you have checked out. But in our case, we don't care, and for the sake of brevity and we're lazy, we type head because we don't want to type a commit hash. So remember the refspec, source, colon, destination. So remotely in Gerrit has this refs for thing that is an interface that it provides. And so Git. So if it was just a pure Git repository, let's say you were pushing to a pure Git repository and you weren't actually, it wasn't actually Gerrit, and you did head colon refs for master, remotely, it would actually create, when you do a show ref, it would actually create a refs for master reference. You understand what I say when I say that? So remember, source, destination in Git. So when you're pushing, if you have a refs, heads, master, your source is refs heads master by default, and when you're pushing to refs heads master, updating the remote master, right? It's the destination. Well, in this case, we're saying push head, which we've replaced refs heads master with head, because we're lazy, or awesome, depends on how you look at it. And our destination is refs for master. So if we were pushing to a raw Git repository that was not Gerrit, it would create a remote reference called refs for master, where it would land as its destination. So if you log into the Git server remotely and do a git show ref, there would actually be a reference called refs for master. But as I mentioned, Gerrit doesn't allow that. It has like a pseudo Git interface. So it actually captures this and does Gerrit things with it. But I wanted to point that out so that way when you're pushing, you can say, hey, I'm actually pushing a refspec here. You're not actually, it's not like magic, it's still Git. It only matters how the server handles it. So if it's Gerrit, it's going to handle it in its Gerrit way, creating a change set and all that stuff. If it's a raw Git repository, this command will still work. It just will create a reference. So I just wanted to rehash the refspec a little bit because I realized some eyes got a little glossy when I was talking about refspecs, and so that's why I went over it again. But we get it. Origin, destination. And if you're pushing, the origin is you, and the destination is the remote. If you're pooling, the origin is the remote, and the destination is you. So that role changes depending on which way you're pushing or pulling. So, all right. I think we're done with the whiteboard. Although you might call me a liar when I start using the whiteboard again. Terror bad. So, next I have on my docket, stashing. What is stashing? So, as always, there's help documentation. Git help stash. Stash has a couple of commands associated with it. There's list, you've got show, you've got drop, which essentially drops it from the stack, pop or apply, branch. The only commands that you really care about that I'm going to really go over here is maybe show. I'll show you show because it's still useful. But you have list, show, pop, and save. So the stash is essentially a stack. We're all somewhat familiar with development concepts, right? So you know what a stack is. You first in, last out. Yes, that's a stack. First in, last out. So when you do a stash push, or actually in this case, the push is the save. When you do a stash save, it's pushing your changes into a stack. And when you do a stash pop, it is popping those changes back off the stack. So let's go ahead and make a change. README. Actually, I probably did it in the bad branch. Let me reset. Tree. Let's check out. Let's check out master. That's a good one. Let's check out master. So here I'm on master. I make some changes. README. Another change again. Oops. Git status. I've made some changes. Git diff. You can see what change I made. Add it again to the end of the line. But you know what? You do a git branch minus v just because you're like, oh, you know, I kind of forget what branch I'm on. You go, oh, I actually wanted to be on my test branch, my test 2 branch. I actually wanted to be on test 2. So if I do a git tree, you see that, you know, it was easy for me to make that mistake because test 2 and master were both pointing in the same place. So no matter who I checked out, you know, it would look the same on the file system. So, oh, you know, I made my changes in master, but, you know, we decided as a team we weren't developing on master anymore. I should have made that change in test. So what do? You do a git status. Okay, I have changes here. So now you can do a git stash save. Saved working directory and index state, work in progress on master, and it tells you what commit hash it saved it from, so it tracks it. If I do a git stash list, here it says, okay, here's all the stashes that are inside of your stack. If I make another change, you know, if I make another change to README, and let's say I want to end sweet to the README, git status, git diff, we have a sweet change here. Now if I do a git help stash again, you notice that when we save it, we can include an optional message with it. So let's save this one with a message. I'm going to say git stash save my sweet change. So now git tree, you see where nothing, or sorry, git status, nothing, our working directory is clean as if we had reset it, as if we had first checked it out for the first time. If we do a git branch minus v, you see we're still on the master branch and at this hash. But if we do a git stash list, we can see we've got a couple of stashes on master. The first one was that whip that we had. It automatically filled in the commit message here, saying the commit message was the hash along with that. But in this case, since we provided one, my sweet change, when it pushed it onto the stack, it overwrote that. So we've saved it onto our stack. We can even show it. So if we do a git help stash and we want to look at a specific object, let's go ahead and show the name of a stash. So the names are on the left side. So if I do git stash show stash, the name of my stash, I want to look at 1. So 1 is all that's going to do. It doesn't look very useful when you look at it like this because, you know, it just shows you how many lines were changed, and the more lines you change, the more green pluses and minuses there's going to be for deletions and stuff like that. But if we look at the git help stash again and we look at show, we'll see here that, but it will still accept any format known to git diff. So if we do like git help diff and look at the formats it does, we can pass it as arguments to this git stash show command and it'll still do it. But you know what? So here's minus p. What does minus p do? Git help diff, search for minus p. Minus p shows you the patch. So if I were to do a git show again with minus p in it, it shows you not only what files were changed, but also shows you exactly what changed in my stash stack. So let's say, now if you recall our original situation, we were on master, we made some changes and went, I wanted to be on test2 branch, so let me stash my changes. I've stashed them into this stack. They're not actually saved as commit objects, although if we look at the tree, you can still see that the stash objects are in here somewhere. I know they are. Yeah, here's the stash objects. They're still in our Git tree in ref stash. But if we, so now we'll git checkout test2 git branch minus v. I did it again. Git branch minus v. That's why I left it, because I knew I'd do it again. So we're now on the test2 branch, because you could tell a star. Now let's pop one of those stashes off. Git stash pop. So that we've popped our stash off. So if we do git status here, it says, hey, you have changes that you've made here. Git diff. Our changes are that sweet change, because remember that it's a stack. That was the last one that we committed, was that sweet change. Now if we do a git stash list, we still have one more stashed item in there. I don't typically work with more than just one stash, but if you happen to work with more than one stash, you'll have to pop it multiple times. Git stash pop. And it'll pop it again. Error, local changes files will be overwritten by merge. Please commit your changes or stash them before you can merge. Git status. Git diff. It didn't like that so looks, this is the first time I was playing with it. So it looks like if you have multiple stashes, you could think of it as one stash per commit object. Doesn't like that. So one thing that you could do is you can go ahead and commit this. Commit git add dot git commit my sweet change git stash pop. We've now popped it off again. So if we do a git stash list, there's nothing else left in the stack. Git diff. You see there's another change, but let's say we wanted this change to be inside the same commit, so we'll just do git add dot git status. Here we have our modified state, so we'll git commit, but instead of creating a new object, we're going to amend our last object. My sweet change is the message. I'll leave the message just for the heck of it. And so now if I do a git status, it shows that our working state is clean. If I do a git tree here in the test2 branch, wherever it's at, yeah, here, in the test2 branch, it's only one commit ahead of where master was. So if you follow the dotted lines all the way back, it's only one commit ahead instead of two commits because we amended. So now if we do a git diff head tilde1, tilde1 just says, give me the hash of the last object right before head. Or you could say two objects ago, but I'm going to say one. And you see, our changes are combined because we have committed it, popped it off the stash, added, and amended. So that's stashing. Stashing is essentially, to put it in brief terms, is when you make a change on one branch and you're like, crap, let me stash them real quick, switch branches, and then pop it off the stash.
But when we do a git slash pop, right, it will pop everything, not just one thing, right?
Pops one item. So if you have 3 items in your stack, it only pops that last item that was pushed onto the stack.
Or if you want all the items.
Well, we just tried that. We tried popping multiple items, and I don't think there's an easy way. And if there is, I'd have to read the documentation to find out. So you know how the Git help works, so you can go ahead and start your self-learning process and research that later to see if it's possible. And by the way, that git head tilde1, that, if you read the Git revisions document, that will explain what that is. It gives you all the different ways that you can
Fetches that fetches the hash of the last commit item for.
Yeah, so if I do a git log, head is here, head tilde1 is this hash.
Okay.
It's shorthand for the hash right before head.
Okay.
So I could have done git diff that hash, and it would have effectively done the same thing. git diff head till day 1. Or you can go 2 hashes ago. Now it's a combined diff of 2 hashes ago. So they're just little shortcuts. Git help, git revisions explains all the shorthand stuff that you can look at. So that's stashing. We all cool with stashing? It's fairly straightforward. Really the only commands I ever worked with, most of those commands that I showed you, I learned right before teaching you because I read the help doc real quick. The only commands I've ever used is git stash save, git stash pop. Those are the only 2 commands you really need to know. You almost never need to list it unless you're trying to do some hackery with tons of stashes in your in the stack, which I don't recommend because obviously that was kind of painful when we were trying to get them all off. So
git stash is the same as defaults to git stash save?
I don't know. I always explicitly say git stash save.
Okay.
But if the help documentation says so, git help stash. So git stash with no arguments looks like save is an optional argument. So yeah, by default, git stash will execute git stash save. I've always been explicit. So that's stashing. Cherry picking. Let's talk about cherry picking. I lied when I said I was not going to the whiteboard. So let's say we have 2 commits here. You have a master, your master's over here, and at some point you branched from here and you made a commit and you called it my branch, MB is what I'm going to call it. Actually that's terrible. I'm just going to call it test. So I'm just going to label this with a T. This is marker 6. So this is our T branch, this is our M, I'm going to call master. And so let's say, oh, you know what? I don't like me being on this other branch. I kind of want that change just to be in master. So I'm just going to cherry pick it. What a cherry pick all a cherry pick does is it changes the parent hash of that commit object. So it goes, whoop, I'm your new parent. Everything goes that was in here. And the only thing changed is the parent. And if the parent changes, then the hash changes. So it's a whole new commit object. So this object still exists. When you cherry picked it, it took all of the diffs, all the commit message, all the signatures, all the committers, everything that was in here, and applied it to here, but all it did was change the parent. And that's the mystery of cherry picking. And sometimes when you cherry pick, let's say there is a merge conflict in here. So let's say you made changes and let's say line 50 in here was changed, but also line 50 here was changed. When you do a git cherry pick this thing, it'll say, okay, I cherry picked it, but there's a merge conflict. Resolve it. I need a human. And so just how we resolved that with the rebase, sorry, I keep pointing at the screen. Just as we resolved it with the rebase, when we were rebasing before and we encountered that merge conflict, or that merge, the workflow is going to be the exact same. It's going to say, both have changed in README. And then when you open up README, it's going to show, okay, well, here's where you're cherry picking from, here's your current head, here's the conflicts, resolve them. And then when you're done resolving them, to mark the resolution, you git add the file, and then when you do a git status, it'll say changes to be committed. To finish this, git cherry pick -- continue. It will actually be in the help message there when you do a git status. And that's it. And that's all there is to cherry picking, is you're just cherry picking single objects. You're sniping them from other places in the repository and saying, I don't care all the objects that are leading up to it. I don't even care if you have awesome changes in between. I am just explicitly picking this single object. I am cherry picking it. I am putting it in my space. I still have the board over. So, and then master moves up. you can cherry pick it. But it's a whole new commit hash, so you don't have to worry about. And because test branch was pointing at this, we didn't actually modify the test branch. That reference is still pointing at its hash. We just said, I want to cherry pick test. And when you cherry pick test, test is pointing at this reference. So get new, okay, it's pointing at this object, so I'm going to cherry pick this specific object. That's it. So that's about as hardcore and advanced as you can get as far as understanding the internals. Really, that's all you need to know. Because as you start reading the documentation, like all these pictures that you see me drawing, when you do git help, like git help rebase, it shows little ASCII diagrams of O's and paths and trees and saying, hey, this is what's happening. And I think it designates this new object. So here's the origin object. It adds a little tick mark here to say, hey, this is A. So here's commit A. This commit is A tick. Because to denote that, yes, this was A, but it's a whole new object when you're reading the help docs. So that's everything. From your scenarios, you had retrieving previous code, check out your hash, check out the commit hash. You can cherry pick from it. There's a number of things that you could do. Squashing works the same way. So if you wanted to have a whole group of things, you have multiple objects that you squash into one, creates a whole new hash with a unified diff.
So squashing, I've never used that before. Or that just combines multiple commit objects into one?
Yeah, squashing combines multiple commit objects. There's a couple of ways to do it, but my favorite way is to use interactive rebase. So if you look at the screen here, git log, let's say I wanted to squash these two commits into one commit because I deemed I liked them better. So I could say git rebase interactive head tilde I think 2, go back 2. So yeah, so tilde 2 is this commit hash. And so here, this is the older commit, this is the newer commit. Here's the commands that you can use. So right now, everything is pick. So if I were to :WQ, if I were to right quit this right now, it would just cherry pick everything and say, object, object, object. And their hashes wouldn't change because I'm just picking the same object with all the same parents, so no hashes have changed. So it leaves you in the exact same state. There's a couple things here. Here's squash. Use commit, but meld it into the previous commit. Fix up is another type of squash, like squash, but discard the commit's log message. So we'll do a squash here. I'm going to go ahead and say squash this newer commit into that older commit, :WQ, and what it's going to do is it's going to bring up this, and it's preserved the commit messages. The commit message from one, the commit message from the other. Hash marks are ignored, so comment blocks are ignored. So let's say another sweet change, another commit, another sweet change there. So here's our squashed git tree. Here's our test2. Everything's been squashed down into a single commit object. So these two commit objects I squashed, and test2 is now up here in that squash. And if I were to do a git diff head :1, it's all the changes combined. That's squashing. It's really simple. Once you understand a little bit about what's going on under the hood. A lot of these commands, the magic is unveiled once you understand. As soon as anything changes, it creates a whole new hash. One of the things you might read on the internet about warnings with rebase and stuff like that is that you're modifying history. So in the case that we use it here, we're only modifying our local history. So I'd like to touch this just because this is a common topic. Whenever you read about Git, you hear that history should be immutable and you should never modify it because you mess up a bunch of other people on your team. But when we're actually doing rebasing, so when you're actually doing rebasing, you know, you have your local master, but you know, someone might have made a change in origin master. And so when you rebase, it first rewinds it, fast forwards, and then replays your new commit here, and then moves master to here. And then when you push, it pushes from here to here, and so your origin master remotely gets here. So the history we actually wrote was our local history. However, one of the things you have to look out for is if, let's say you do an interactive rebase, you go, oh, I don't like these 3 commits, let me squash them. I want these 3 commits squashed into a single diff. I've squashed them. We have our new unified commit object that is master, and all of these I didn't like, so now it's a single commit. Now let me do a git push to origin master. It's going to go, I have no way to handle this. By default, Git will refuse this. If you do a force push, what it's going to do is it's going to go, I am no longer referring to that. I am now referring to your new object. And this, in effect, on the remote side, you have modified the history. And so this way, when other members on your team try to fetch, their repository is going to be in this crazy state because their origin master was pointing to this thing, and they're going to be like, my history's changed, what the hell? So this is fortunate for you, we don't allow force pushing, so this is not something you have to worry about working within Gerrit. But when you move to GitHub Enterprise, or if you move to GitHub Enterprise, it does allow force pushing. So you have to be mindful about how you modify your history. And really, origin master should only progress in history. If you need to revert something, you should create a reverse patch, apply those reverse patches changes into a new commit so that it can advance only. So, yeah. Cool. I think I've used up all of our time. I did. So, yeah, and then we talked about ahead and behind, and then one of the things that you mentioned here is how can I have updated how can the status of my local machine still be ahead of one commit after rebasing and updated? And that's why, because when you rebase, it replayed your commits on top, and you're still ahead of origin master by 1. Recall? So keep handy that git tree alias. It's a lifesaver because it gives you a bird's eye view of your entire repository. And whenever you get into a situation that is kind of scary, you can always go to git tree, which I had emailed everyone got, right? You just add that to your git config. It's an alias. And that will save you most of the time. That's it. We are done.